Hello everyone, September 29th. All right, let's get into it. It's in the morning, feel good. Split linked list in parts. All right. Given a head of a single linked list and integer k, split linked list into k consecutive linked list parts. The length of each part should be as equal as possible. No two parts should have a size differing by more than one. This may lead to some parts being null. What do you mean by some parts being null? The part should be in the order of occurrence, and parts occurring earlier should always have a size greater than or equal to the parts occurring later. Return an array of the k parts. So I'm going to do a 5. That's what it means by having empty. Okay. Last element is null, but extreme representation of goodness. It's null. So it's going to be what? Null and null. Okay. So partition to 3. So we have 4, 3, and 3. So 1000. Okay, k equals 50. All right, and I mean, definitely when it's a linked list, you shouldn't be allowed to copy this out into an array and then handle it by an array. I think you have to do it linked list way. So when you're given a head, you have no idea how long this linked list is, right? So you have to decide. Let me see. What if I say k equals 1? Then you simply return the head, right? If k equals 1. What if k is equal to 2? Well, if k is equal to 2, then you will, let's say you get 2 pointers, right? One is walking twice as fast. And then once the other one walk to the end, the first one will walk to the center, right? To the center. Well, let me see. So I walk 1, I walk 2, and to the center, right? And then we'll call it, it will be the center, right? If it's this, so 1, 2, right here, and then 1. Interesting. Oh, we can figure it out. So if it's 2, let's go. What if it's 3? That means 1 has to go triple as fast, right? So if I go 1 step, like I'm thinking like adding a dummy. So 1 step, and then we go 1, 2, 3 step, right? And then 1 step, 1, 2, 3 step. 1 step, 1, 2, 3 step, right? And then 1 step, and 1, boom, end. So I end at 4, right? So the first one, the next one should be the next one, right? The next one. So this will, this is the dummy. So this will be the dummy, right? And then we can add this one in. Now dummy is going here. So we get the second pointer back. Now we go 1, 1, 2, 3. 1, 1, 2, 3, 1, boom, exit. So now the second one we can add dummy next, it'll be 5 adding to it. So now we're currently at 7. 7 is a dummy, right? And then we go 1, 1, 2, 3. And then, okay, 7 is a dummy, right? I go 1. And then 1, 2, 3, I'm at the end. So I go another time, and then boom, it ends. So we add 8, dummy next 8 to it. But now we have trouble because, because I shouldn't, right? I shouldn't. So like this is the dummy, I shall go, and then that's the end. Otherwise, go 3 times as fast, right? We'll go 3 times as fast. That is interesting. If we go 3 times as fast, am I here, right? I'm here, right? And then if I have only 2 steps left, right? 2 steps left, then it's fine. But if I have more steps, but if I end at 8, right? And then we go 1, 2, 3. Now let's change. What if I don't have dummy? I just start with here, right? So the starting point is here, and I will go 1 step, and I go 1, 2, 3, right? And then 2 steps here. 1, 2, 3. 3 steps here. 1, 2, 3. And 4 steps is here, and boom, end, right? So this is the ending point. Oh, we ended 4 as well. That's bonkers. We ended 4. Okay, so we ended 4, but we do 1. But should we include 4 or should we not include 4? Let's say we don't include. Alright? Say we don't include, so the next one will point into 5. Okay, from 5, we go 1, 2, 3. Right, now 6. 1, 2, boom, end. So we do 5. And then we have trouble because we're at 6. That is, how do we handle all this steps? Huh. Let me draw it out. That's 10, right? It's 10. I mean, let's do 9. Right? Let's do 4. 2, 3, 4, right? And then with k equals 2, right? So k equals 2. I have, yeah, that should be good. Number of nodes 1,000. This will be 1,000 times 50. So I think this is the solution, but the difficulty is to figure out when do we end, like where's the starting point, and all that kind of good stuff. So if I have a dummy, all right, and then we all start from a dummy, then actual pointer move 1, and then we move 1, 2 here, and then actually move 1, and then move 1, 2 over here. So if I move to the tail, right, then it shall stop, right? Because so one of the nodes already moved the tail. Then whatever the first node is, that shall be the one. The dummy for the next one, right? Dummy for the next one. So I say, okay, that's dummy for the next one, so we get 1 in, that's cool. And then move second pointer here. So I move 1, we go 1, 2, boom, end. Well, it's end, so we're gonna do the dummy's here, so dummy to the next one, so we have it. But now I'm here, and then I go 1, 2, and we don't have anything. And let's go 1. How do we reason? Yeah, exactly. How do we reason? How do we reason this? When 1 reaches the end, right? It depends on its even numbers or odd numbers, right? So it will reach the end, then the other one will reach a halfway point, right? Halfway point. And then when talking about a halfway point, is the halfway point. Yes, exactly, that's the halfway point. And a halfway point should be the next one. That's a dummy value, right? I mean, we can count. What do you expect? Like, what I'd expect is I go 1, right? And then the other one goes to the end. That means that's the half, right? It's the half. So all this does is give me half. It doesn't give me, oh, I think I know. So by doing the first round, we do 1 round, then I can know the number of nodes that shall be included, right? That's the value of going 2 pointers, is we use 2 pointers, now we know the number of nodes, actually the higher bound of the number of nodes, and also we probably can figure out based on where the second pointer lands, right? We probably can figure out the total number. Let me analyze it again. So, okay. All right. 1, and then 1, 2. So either if I don't add a dummy, we start from whatever we have, right? And then we start going. So we go 1, the other one go 1, 2. It's not at the end. And then we go 1 again. The other one go 1, and boom. So we have 2 left, right? So now we have 1 left. So we have 1 remaining. That's the number of steps. But that's harder to reason. No, I like to add a dummy. If I add a dummy, then the number of steps, the number of links is the same as the number of actual nodes, right? So I add a dummy, and then boom, 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 and then we go to the end, and then the remainder is 0, right? That means the total number of nodes can be divided by k. That means everybody should be the same length. And then the length can be computed by how many times the first one moves. The first one moved 1, 2. The first one moved 2 times, right? 2 times. So we know each will be 2. And then we just need to move down 2 times to collect the rest. Okay, so how about we go back to try this one, right? We go back to try this one. So now we have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We add a dummy at the front, and then we're gonna do times 3, right? So first one come here, second one 1, 2, 3, right? Next one come here, 1, 2, 3. Come here, 1, 2, 3. Come here, 1, and that's it. So we have remainder is 2. So it's 2, 3, right? Remainder is shouldn't 1, 2, 3 shouldn't. Oh, that's because we have, we have 10, right? We have 10 steps. Oh, the remainder is, hold on, what is remainder? Remainder is the number, is the extra steps that we have to take. No, it's not 2, it's 1. Remainder is 1. That what I'm saying is the faster point is here, and then we go once, then we end, right? So that 1, that is the remainder. So remainder is 1, which I know by doing that, I know the total number must be 3 times k plus 1, which means the first, and then we calculate how many steps we do on the first. So the first did 1, 2, 3, 4. So first did 4. So we know the next one will be, because it's plus 1, right? So that we have only 1 with extra, and the others must be all 3, right? So based on this plus the remainder, we know how many like longer we need. So now we know only one is needed. So the next one will be 3. So we just compute 3. Next one will be 3, and then we're done. Okay. So let's also try, I have 2 examples. Let's try this 1, 2, 3, right? 1, 2, 3. So we have 3 nodes. We add a dummy, then the slow one we go once, fast one we go 5 times. So 1, 2, 3, boom, and so the fast goes 3 times. So its remainder is 3, which means the whole thing is going to be 5k plus 3, right? 5k plus 3, and plus 3 means we'll have 3 segments that are 3 segments that are the same as the current value. So the current value is 1 node. So we know the next one will be 1 node, next one will be 1 node, and then we're done, right? And then the rest, because we need to divide into 5, so the rest will be 0. I think I know. Okay, so let's try it. This is a good question. This is an interesting question. Very interesting question. I like it. I like it a lot. Wait, what happened? Why there's nothing here? Oh, PY2. This is unfortunate. Let me make the change. Ever since I made a mistake in typing, and this is haunting me. All right, now it should be good. Yeah, there we go. Now it's good. All right. I just realized I haven't used PUDB for a while for debugging. All right, so for one thing, we don't need deck. All right, here's what we need. Copy this. Oh, we will not do test cases because I'm just too lazy to write test cases. Anyway, so here's what we're going to do. We're going to have a slow and a fast. Have a dummy, right? So dummy is going to be list node. Next is going to be head, right? And slow, fast, both are going to be dummy. Start with dummy. Yeah, let's just say slow and fast, right? Then what we're going to do is we're going to have a count, right? Have a count. Oh, we have 2 things. We need to count number of slow. So slow steps. So slow steps and fast steps, right? Both going to be 0 to start with. Now we're going to have while fast, right? While fast. And now we're going to move forward, right? We're going to move forward. How do we move forward? So we move forward by, hold on. I should not say while fast because I'm going to do the fast iteration by itself. So it's going to be while true, right? And then we're going to just let's move fast first, right? Move fast first. How do we move fast? We say while fast, right? Fast equals fast.next. And every time we do that, fast steps plus equal 1, right? And blah, 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 when we're done, while fast and, no, for this in range, k, we're going to do 5 steps, so this one, this, in k, this equals if, right, if fast equals this, and then else, and a break, right? So this will accumulate the number of steps that fast takes, right? And then what? Once we're done, right? Once we're done, how do we know we hit the end? If fast steps, right? So we go to fast, and then we're gonna go slow as well, right? So it's slow. If slow, no, slow will always have. So slow equals slow dot next, right? And then slow steps equal 1. So fast first move, right? After fast move, slow move, right? Let me see. 1, 1, 2, 1, 1, 2, and then fast move again. So yeah, fast first move, and the fast cannot move, then slow should not move. Fast move first, so we have to check first, right? So we say if fast steps is smaller than k, right? It's smaller than k. That means we haven't moved enough steps. If it's smaller than k, then we break. Otherwise, slow move and fast steps go back to 0, right? So this one will give us, when this is done, will give us a number of slow steps, number of fast steps. So fast steps is going to be the remainder, right? The remainder. So now we have a res equals this. Now we're going to start putting things in. We can always put the head in. So we're going to put head in. Now what? Now what we're going to do is slow, right? Slow is at the dummy position. Slow is at the dummy position. So what we can do is actually, let's do this, right? And then we're going to input the range of the current slow count, slow steps. And after that, we're going to do slow step minus 1, right? So here's what we're going to say for this in range fast steps, right? That will be how many partitions will have, the number of partitions that will have the same length as slow steps, right? So we can just do res.append dummy.next, right? And then we're going to move forward the number of steps of the slow steps. How do we do that? We're going to say for this in range slow steps, right? And then we're going to do slow equals slow.next, right? And then once it's done, slow equals slow dot, so we do whatever slow steps we need to do, and it will end. Let's say 1, 2, 3. It will end. But we do this, and then dummy will equal slow, and then slow will keep going. Once it's done, we'll go back at the dummy, and then boom, 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 when it's all done. So that's the number of partitions with slow steps number of elements, right? So that's this part. Now when this part is done, we're going to do the remainder, right? The remainder. So the remainder will be for this in range k. What is the remaining? No, that's not the remaining. Yeah, the remaining is k, right? K minus fast steps. That's the remainder we have to do. And each one will have slow steps minus 1, right? Slow steps minus 1. How do we do that? We say res.append, right? .append dummy.next, right? And then dummy will equals slow. And then for this in range, I'm going to go slow steps minus 1, and then slow equals slow.next. And then if you think about in this case, right? So the first three, we will handle all this, and then it will land. Eventually, will land. Let me see. So we land here, and then we go, 2, 3. So dummy is here, right? Dummy is here. I need to reset the dummy when it's done. Dummy is this, slow, and then we go, coming back, dummy down next, and dummy becomes slow, slow move forward. So once it's done, dummy needs to be moved to the current slow. Now, dummy is slow is here, so append dummy down next is this one, right? And then dummy equals slow, which is a no op because we have already set dummy equals slow. But we do need, I can just put dummy equals slow at the beginning, but no, yeah, I think we can just put dummy equals slow at the beginning. We put it here, right? Dummy equals slow, then we don't have to do this because at the beginning dummy will equal to slow, and then dummy down next will be none, right? And then for range, so slow steps is 1, so it's 0. So slow equals slow now does not call. So dummy equals slow is still here. So we append the empty. So these are the number of partitions with slow steps minus 1 number of elements. And then once we're done, we're going to return the rest. Okay, so let's give this a shot. I'm not going to test it. I'm just going to throw this. All right. Okay, let's try it. Okay, that's good. I mean, technically we can test this. I don't think there's any issue with this. It's just kind of lazy. Don't want to. I don't want to write extra code. Expected answer. And my answer. That is not correct. Come on, man. That is not correct. Okay, so I need to do some, yeah, I'm gonna just swallow it. Let's just do it. Okay, so we need a test case, which is not, I mean, not too bad. Right? It's not too bad. It's we had 1, 2, 3, 4, 5, 6, 7. That is excessive. How does that come to pass? And then 3, right? And the result shall be this. Oh, I have to change the code significantly. It's fine. All right, so this is gonna be, oh, that's not a head. Ha, that's gonna be linked list and K, right? And then we're gonna create a linked list. My. So how do you create? So I'm gonna say dummy equals list node, right? Nothing, and then node so have a dummy to start, and then the first one will be node, right? And then node dot next equals, yeah, so node equals dummy. Wait, how do we do this? Head. The first one will be this, and on next, node equal node on next, and then node of val, right? Node of val Then why do you need a dummy? Yeah, I don't think we need a dummy. It's just we're gonna do a head, all right? And node equals head, and then for val in linked list, we say node.val, right? Node.val equals val, and then node.next equals list node, and node equals node.next. And then we create a linked list, and we can say head, right? So this one is split. Let me say head k, and the result. Oh my god! All right, so we're gonna recreate a result list, which is gonna be result list, right? For equal to this, and for r in res, right? For r in res, now let's start append this, right? And then for r, we're gonna say node equals. Oh, r is node. R is node for node in this, and then just say while oh, I see the problem. I see the problem. I forgot to put the end to it. Ah. Oh, shoot. How do we do that? So when append, right? So slow equals slow down next. And then eventually we will reach, so we are here, right? That's the current slow. And now we say dummy equals slow. And oh, and then, oh, there's a lot of issues. And we start at 4. My, there are too many issues. Okay. It's just one at a time. Let's handle it one at a time. So first of all, in this case, we have to go dummy.next first. Right? So dummy currently is here. Dummy is here. So dummy.next, we put this in. And then dummy equals slow. So slow is here. So dummy goes to here. Right? And then dummy equals slow. And then slow equals slow down next, whatever. Once we're done, right? Once we're done, we going back up, right? So res.append dummy.next, right? But the dummy.next need to seal it. So we after we do this, dummy.next need to be none. We need to seal it. Dummy.next need to seal it. So that's that. And here, once we're done, dummy equals slow. So we go back, dummy is slow. And then dummy.next. So this one, put it in. All right. And then slow move forward. Right. Slow move forward. Once slow move forward, dummy will go to slow. So after we go this, dummy.next need to be none, right? We seal it. I put it in, we seal it. Okay, let's try this one. Yeah, kind of still, I don't have the Ghana to write all this. I mean, it's not hard to write, it takes time. All right, let's try it again. I have some issues. Dummy equals slow, and then because slow and dummy is at the same position. That's why. That's why. Which means we shall do the same way as this, right? Which means we shall move the slow first, right? We shall move the slow first. Yeah, we have to, let's just set dummy equals slow, right? Dummy equals slow, and then we're going to, we need to move the slow first. We move slow first. So it'll be the same logic as here. We move slow first. We separate the dummy and slow. So move slow first. When slow cannot move anymore, then we do this. All right, and then we do this. We append dummy.next, and dummy.next is none, which is fine because slow is already down the line. And then dummy equals to slow. Okay, let's try this then. Let's try this. Here we go. All right, let's try this one. Pending. Still we have trouble. All right. Anyway, all right. Let's try this. So our list dot append. So So we're gonna go while node. Yeah, let's say R. So we don't have. So we're gonna say node equals R. While node R list -1. I just say temp equals this. All right. And then I say temp dot append R dot value. R equals R dot next. All right. And blah blah blah. Once we're done, we say R list dot append temp. Okay. Now when we check, for R list. All right. That's wrong. Let's run it. Optional is not defined, so I need to define optional. None type has no attribute next. Okay. It's here. All right, let's see. Slow steps -1. Oh, this one's. Wait. Probably have some error in creating this. My. Head. So node equals head. While node print node dot val and equals this, and then node equals node dot next. I'll try to see if we got this one right. We did not get this one right. So for val, it goes to next, and then the last one. The last one. We have trouble with the last one. How do we avoid that? So what we want is the last one. When we say node dot val equals I think to avoid this, we do need dummy. So we have a dummy here. So node equals dummy, right? And then for val, blah blah blah, and we just say node dot next. Right? Node dot next equals this. Val equals val. Then blah blah blah, and then node equals dummy dot next, right? And then when we here, this is not gonna be head. It's gonna be dummy dot next. I'll run this. Okay, so this is good. We just have a different problem. R in res, node equals R. none type has, the rest will give me none type? What? I think this one's correct. Node equals, I don't need this. Right, so this one's correct. And then dummy dot next, that's the head. And blah blah blah. So let's see, print r dot value. I have 1, and then that's it. I feel like there's still something is wrong. It's the same algorithm. So the problem is with, still with this? Come on. Really? Let's say print res. That's what's res? Res has 3 nodes, right? And then one node is 1. The trouble is, oh, I see. I see the problem. Yeah, that was my bad. That was my bad. Okay, so the problem is node equals r, while node, it has to be node. Not r, it has to be node. And wait, did we print out one more thing we don't supposed to? Oh, the answer. It's gonna be r list. There we go. Okay, now we can debug. Alright, so the first one is wrong. That is very interesting. Alright, let me see where the slow and the fast steps are. So let's print slow.val and fast.val and slow steps. You know what? So slow.val and slow steps and fast.val and fast steps. Alright, that's what we want to do. 3 and 3. Oh yeah, fast.val, fast is gonna be nothing. So let's just do this. Don't print fast.val. So slow is at 3. That is not right. That is not correct. It should be 4, right? So we have a dummy, slow, fast, a dummy, and then we go fast first, right? Fast, we say if fast, so fast equals fast on next, so we go 1, and then we'll arrange k. K is 3, so we go 1, 2, 3, right? That's first round. And then fast steps equals to 3, that's good. So we break. So we don't break, then slow move to 1. And then fast steps back to 0. Now we go 1, 2, 3. Slow go to 2. Now we go 1, 2, 3. Slow goes to 3, right? Here is the thing, slow goes to 3. And now I go 1 and boom, break. So fast steps is, fast step is 2. It's supposed to be 1, so fast step will go 1, right? And then going back. Ah, okay, I see where we need to change. Okay. And then break out. Break out. So first of all, this should be fast dot next. Right? And then when we break out, it has to be if fast steps smaller than k and larger than 0. Because if fast steps is 0, which means I'm here, then the slow shouldn't move. But if fast steps actually moves, the slow needs to move. And in this case, the fast steps is 1, and the slow need to keep moving. So slow will increment, not fast steps is 0, come to the front, and fast dot next we do, and fast dot next is nothing. So we stop at 10, right? Fast stop at 10. The next one, fast on next, no. So 0, boom, we break. So this one will give us 3, 3, and 1. That's still 3, 3, and 1. What? Fast steps is oh, I break. What are you doing, man? So it's just if fast steps, right? If fast steps is larger than 0. Now I still that wait, what am I trying to do? If it's 5, if it's k, then we continue, right? If it's less than k, yeah, so it's fast steps equals 0, then we break. Yeah, now we got 4, right? We got 4 coming out. Now we got 4 coming out. Now coming here. Range fast steps. Oh, we do fast steps. Okay, let's not do fast steps here. We do fast steps here. We initialize in the top, right? Initialize the top. Then when we do this, oh, fast steps still 0. Oh yeah, fast steps is always 0. Okay. No. We have better ways. So we do this, blah, 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 right? And then come in here, and we want to move the slow, right? So we say if and then we want to preserve the fast steps. How about we don't check the fast steps, right? We don't check it. We go here, blah, right? But before, we're going to check if not fast on next. So we already at the end, that would break it, right? And this way we can preserve the fast steps. You see this? We have fast steps is 1, right? We have fast steps is 1. Now I'm coming here, so we're going to append dummy. Dummy is still at the front. Dummy dot next, okay. And we append dummy dot next, and the slow is at 4. Right? Slow is here. Slow is here. Dummy is here. So, oh shoot! How can you do dummy dot next equals none? A lot of problems. A lot of problems. All right, so dummy is a front, right? Oh yeah, dummy is the front. So dummy dot next is none. That's fine. And then dummy equals slow, so dummy move here. And then in slow steps, which is 4. Ah, shoot. That is our problem. That is our problem. Because we already handled it. So fast steps minus 1. Because we already handled it. So fast steps into minus 1. Right? Fast steps minus 1. And this we have to put head in it. Rest is head in. So the first one we already incorporated, right? And then for fast minus 1, dummy needs to go to slow. Yeah, dummy needs to go to slow. Dummy needs to go to slow, and dummy goes to slow, and we let the slow go, right? And after slow is finished, we add the current one. So here's the deal. Dummy go to slow. Dummy go to slow, and then slow moves. And after slow moves finish, slow is the new dummy position. And we're gonna say rest.append dummy.next, which is the current that we just moved this part we put in. And then dummy is the front, .next equals none. So front sealed it. Now we break out, dummy is at the front, slow is at the back, and this one's already added into it. So we say dummy equals slow, yes, that's correct. And then we're gonna go inside, slow gonna move, so we can put this one inside, right, slow gonna move, blah, blah, blah. When we finish moving, rest.append dummy.next, that's true. And dummy.next, we sealed it. Let's seal the previous one. We don't have to do this. And then we keep going until we finish. Now when we finish, dummy is going to be slow moving, right? And then rest is going to append this part. And we don't have to do another dummy.next equals slow because we're at the end. So let's try this. This one passed. All right. Let's copy and paste this. Oh, hold on. Let's try. We have another test case. It's 1, 2, 3, 5. Shall return 1, 2, 3, and 2 empty. Right. Yep. Both pass. Where did I print? No, I need to print. Wow, it took so long. It's an easy it's not a difficult problem. It's all right. Try this. And of course, we're going to test a few more. Let's say 11, 12, 13, 14, 15, 16, 17, 18, 19. That's a prime number, right? So we're going to go, let's say 4. Looking good. Test the prime number. Let's go like maybe 14. What will 14 go? That's a good question. 14, that's too much. So we're gonna do. Oh, nice. All right, last test. Let's go 8, and can be divided. Let's say let's do 3, 6, do 6, 6 parts. Should be 3 each. All right, I think we're good. Submit. Oh, this could be empty. Ah, shoot. Which part? Which part? Empty list. I mean, let's see. Empty list. I'm gonna have 2 ways to handle empty list, right? It should be this. 2 ways to handle empty list. So we have problem here. Dummy equals slow. Should we? Yeah, let's just handle at the beginning. If not head, return head. Right? If not head, return head. And in this case, actually, it reminds me we need to test also, let's say, 1. 3. That should be 1, and nothing, right? Alright, this is fine. I just forgot to handle the empty case. Alright, try it again. Pending. What? Oh! Ah! My bad. Oh my god. It should be times. Man, this is not a single one. It's 3. Lord. I have to times kick. I can't do that. I cannot do that. So for this range, okay. Alright. This is unfortunate. Very unfortunate. Could have avoided. I'm not gonna do it. I'm gonna test it first. So it's empty. It's a 10. Let's see. Yep. Alright, now submit. Pending. Judging. Accepted. Alright, so I don't think this is a I don't think this is too difficult, but there are quite a few mind twists that one needs to go through. First of all, we use slow and fast pointers to obtain the number of nodes, right? The number of nodes, the larger number of nodes in the partition, and the number of large partitions. This is achieved by letting the fast node to go k steps at a time. Essentially, when the fast node reaches the end, we something came up. I'll just end it today. I'll see you guys tomorrow. Adios.